How are we doing, seventh grade? I know that this year is starting off a little bit differently, but I figured to try to help, I would make some instructional videos and put them on YouTube. So these videos are going to be essentially your notes that you will be taking during your asynchronous time. So you can always come back and watch this video. I'm not going to be taking it down. Use this video to help you. And then, of course, come to office hours if you have any questions. So this week, we're going to be talking about proportional relationships versus non-proportional relationships. So let's get to the video.
Today we're going to be talking about proportional relationships versus non-proportional relationships. Now it's important for us to remember that proportional relationships are directly related to ratios. Okay? We can tell if something is proportional when it has a consistent ratio every single time. So here's how we're going to go about doing this. I have this example problem. The table below represents the relationship of the amount of snowfall in inches in 5 counties to the amount of time in hours of a recent winter storm. So what I'm going to do is I'm going to see if there is a consistent way that I can go from my x value to a consistent way that I can go to my y value. So I know that I can do 2 times 5 to get to 10, but I know that 6 times 5 doesn't get me to 12, nor does 8 times 5, or 2.5 times 5, or 7 times 5. In fact, every single time for the rest of these, it's x times 2 gives me my y value. But for this one, it's my x value times 5. It gives me a y value. So is there a consistent ratio that happens every single time? Is there's consistent, constant of proportionality, constant ratio, constant rate of change that is happening? In this case, there is not. No, there is no constant ratio or no constant rate of change. No constant rate of change. Let's look at another one. The table below shows the relationship between the cost of renting a movie in dollars to the number of days the movie is rented. So let's see if I can go from X to Y. So 6 to 2. How can I possibly go from 6 to 2? What can I do to 6 that gives me 2? Well, I know that I can divide by 3 every time. So 6 divided by 3 gives me 2. 9 divided by 3, hey, that gives me 3. 24 divided by 3, that gives me 8. And in fact, 3 divided by 3 gives me 1. So I can look at this as like x divided by 3 equals y. My number of days divided by 3 gives me the cost of dollars. Or if I wanted to think about this constantly, I could say, or the cost of dollars, or the cost in dollars divided by the number of days should in fact equal 1/3. Okay? So is this relationship proportional? Yes. And how do I know? Because there is a constant rate of change or a constant ratio. Constant ratio of 1 to 1/3, or I can do x divided by 3 every time. And I know that my handwriting isn't great. I am working on it, I promise. We'll get better as we go on throughout the year. So I have one yes and I had one no previously. So let's look at another problem here. Bella types at a constant rate of 42 words per minute. Is the number of words she can type proportional to the number of minutes she types? create a table to determine the relationship. Well, I know that for every 1 minute, she types for 42 words. Well, naturally, that would mean in 2 minutes, she would type 84. And if I were to go one more time, it would be 126. And let's just say she decides to get crazy and types for 6 minutes. Well, that would be, let's see, I have 42 times 6. That gives me 12. 6 times 4 is 24. 252. And if I were to type for an hour, it would be 2,520. So is this relationship proportional to the number of minutes she types? Well, yeah, it is. So if I were to make that X and Y, yes, because I can multiply. That was a horrible Y. Multiply X by 42 every time. So I can do 42 times X gives me my Y value. Let's look at another problem here. Mark recently moved to a new state. During the first month, he visited 5 state parks. So I'm going to underline that or highlight that because that is important for me. First month, he visited 5 state parks. Each month after, he visited 2 more. Complete the table below and use the results to determine if the number of parks visited is proportional to the number of months. So, within that first month, he visited 5 parks. How nice. Then in that second month, he visited 2 more parks on top of that 5. So he has 7. And then 9. I don't even really need to know what my number of months is for 23 to know that this isn't a proportional relationship, because there's nothing that I can do to the number of months each time to get to my desired Y value. So, no, this isn't proportional because there is no constant rate or constant multiplication that can be done to go from X to Y. All right, so let's wrap this all up, shall we? So our lesson summary. A type of quantity is proportional to a second if there is a constant number such that the product of each measure of the first type and the constant is equal to the corresponding measure of the second type. So let's use our X's and Y's here, our A's and B's, okay? So I'm going to say our first quantity is, that first type is A times our second, or our constant, which I'm going to label C, equals our second type. You could also do X's and Y's. So X times our constant equals our second value. So that's how I know if it is proportional. There are steps to determine if quantities in a table are proportional to each other, and that's what we've been doing this whole time. Everything has been in a table. For each row or column, calculate B divided by A, where A is the measure of the first quantity and B is the measure of the second quantity, and see if it's the same number every time. If the value of B over A is the same, then the quantities of the table are